Hi everyone, today we're going to be going over Leetcode number 875, Koko eating bananas. In this problem, we can see that Koko loves to eat bananas, and there are n piles of bananas. The ith pile has piles I bananas, and so from this we know that we're given basically a pile of bananas, so it's going to be like an array of piles, and this is going to be an int array. The guards have gone and will come back within h hours, so that's something we'll also have basically, which is going to be h, an int, basically telling us how long these guards will be gone for. So what's the problem actually asking us for? Koko can decide her bananas per hour eating speed, k. So it looks like we need to decide this k value here, which is going to be our eating speed, bananas per hour eating speed. And each hour she chooses to eat some pile of bananas and eats k bananas from that pile. So basically Koko is eating out of this piles array and eating like random piles at a k speed. So k is basically bananas per hour eating speed, and if the pile, so it looks like if the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Okay, cool. That's basically, this is important information because now we know that if we decide that our k is going to be like a certain value, we can only eat that amount of bananas out of the piles array. And so let's say that we're eating more, we can eat faster than the amount of bananas that are in the pile. So let's say that our pile has like one banana and our eating speed is like 2. Just because we ate that one banana and we have an extra banana to eat in that hour, we can't move forward because that pile only had one and we need to wait until the end of the hour to start eating the next pile. So basically Koko likes to eat slowly but wants to finish eating all the bananas before the guards return. So we need to actually return the minimum integer k such that she can eat all the bananas within h hours. So from this, let's just take a look at the example here, and kind of understand like what's going on. So we have an array of bananas where we have 3 bananas, then 6, 7, and 11. And then we also have the h is equal to 8. So 8 is basically how long the guards will be gone for, and we need to eat all of these bananas within 8 hours. So the output here, what we're going to return here, is going to be k. And for this example, we have 4. But let's actually try to understand how they came up with that value and see if we can come up with it using a brute force solution. So in order to basically figure out like what our k will be, we can simply just start passing in like eating speed values and seeing like if we can actually eat bananas within that k time or within that k speed, and see if we can actually finish before the guards return. So let's just start from eating like 1 banana because, or let's make our k1 and see how long that will take. So how do we actually calculate how long it's going to take us to eat each pile? We need to make a formula for this. So in order to eat this pile, we can actually check how many bananas are in a pile. So in the piles array, we'll take the amount of bananas there and divide it by our eating speed k. So let's say that in this situation, our k is equal to 1, and our piles is over here 3. We know that 3 over 1 is going to be equal to 3. So this means that this pile will take 3 hours to eat if we eat 1 banana per hour. And so that's simply how you calculate the eating speed. Let's say that k is equal to 2 here. We know that this will be equal to 1.5, but we can't eat within 1.5 hours. If we have basically a decimal value, we'll just have to round up, because in the problem we saw in the sentence over here that she eats all of the bananas and will not eat any more bananas in that hour, if she's able to consume like the bananas, and then there's still some left over for her to consume. So we know that 1.5 will just basically round it up to 2. So to 2 here. So it'll take 2 hours to eat this pile. So knowing that, we can actually just round up, and in Python and Java, you can just use this method called ceil, which is going to get the ceiling, or in our case, round up that number. And so this is the formula to calculate how long it'll take to eat a certain pile. And so you can imagine we need to run this formula at each index, and then we can add them all together to get the speed. So let's go back to trying out eating 1 banana every hour. So it'll first take us 3 hours to eat the first pile, and then it'll take us 6 hours to eat the second pile. And so that's already equal to 9 hours. So that's not going to work because the guards will come back and we won't be even done with the second pile basically. So let's go ahead and increase the value to 2, and you'll notice that we're just going to basically just increment the k value until we can complete eating, and as soon as we basically meet the time, which is going to be 4. If we do 3 divided by 4, it's going to be 1 because we need to round up. Then the second pile will take 2. The third pile, which is 7 over 4, is also going to be like 1.75, which will be rounded up to 2, and then 11 can be rounded up to 3, and this will in total take 8 hours. And so that we know that once we get to 4, we're actually able to complete this, and so we can return 4 as a value. So the brute force solution here, if you notice, it is going to be big O of n and times k, because we're going to basically go through this array k times, because we're going to, let's say the value here, which is we're returning k, we're going to go through a k times because we need to calculate how long it's going to take us to eat all of these bananas each time. A way to make this faster is actually by using binary search. And so we can use binary search in this problem to get a time complexity of log k n, because now we can actually search faster in the array and get the eating speed. And so I'll show you how to identify this trick within problems similar to this, and let's first actually try to use binary search here and then see how that works. So let's go ahead and figure out like what it means to get a log k value. So let's first see all the possible k values we can actually get within an example from example 1. So we know that the minimum speed to eat is let's call that min k. Our minimum k value is going to be equal to 1. Like, we know that after solving the problem, this is actually not possible, but before actually starting to solve this, in the brute force solution, we had to try out 1. So our minimum eating speed for any problem will always be 1, and then our maximum eating speed, which is very important to note, is going to be actually the maximum value in the array, or found in the array, which is in this case the maximum value found in this array is 11. And so why is that the case? Well, we know that in the constraints that our piles, like the length of our piles, will always be less than or equal to h, which means our h value at minimum can be equal to the length. And so let's say that h in this situation is not equal to 8, but instead equal to 4. We can eat at 11 speed, which is going to be the maximum. So we need to finish all of these within a single hour because we have 4 hours to complete this, and we have 4 piles. So we need to eat as fast as possible, which is going to be the maximum value here. So 11, it's going to take 1 hour, 1 hour, 1 hour, 1 hour, and that's going to be 4. So we know that our max k here is going to be the maximum amount of bananas in a single pile, and our minimum is going to be just 1, because that's just what we'll have to try. So we know that our bounds are going to be 1, or 11, and inclusive, and so we can go ahead and write this out here. And then let's go ahead and check why this will work. So let's try all the possibilities. 1k, eating 1 banana per hour, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So reason we can use binary search here is because we can start a pointer on the left side, and let's call that L, and then let's start on the right side and call it R. So as you know, in binary search, we'll just go ahead and go to the middle value, which is going to be our middle value, and from there we can calculate how long it's going to take us to eat this these bananas, or these piles. And so from that we can calculate the value. So it's going to take us 1 hour to eat the first one, it's going to take us 2 hours to eat the second, and then it's going to take us 2 hours to eat the third pile, and then it's going to take us 3 hours to eat the last pile. And so from there, it's going to take us 8, which means that this value is going to be basically less than or equal to h, which means that we can actually try to find a lower time or a slower eating speed. And so we can just move this r pointer here to 4 here. So we can actually remove the pointer here and then change the middle pointer to like 2 and see what happens. And so when we run 2 here, and so we know that the first one, 3/2, is going to take us 2 hours to eat it. Then the second one will take us 6/2, which is going to be 3. Then the next one is going to be 4, and the last one is going to be 6. And so that's going to be 10 plus 5, which is going to be 15 hours. And so we know that this is not going to be possible. And so we'll move the left pointer here from there to 3, and then we'll go ahead and calculate 3 again and see that 3 is not possible, and then we'll move that left pointer up again. So ln(r) is going to be the same thing, and so the mid pointer is actually finally going to also be f4 here, and we know that 4 is actually going to work, and so we've found a value that actually works for us and is the minimum. And so you can actually see how binary search is beneficial for us in this situation. So how do we identify a binary search problem? And so that's what I kind of want to go over in this video. What is the trick, and how do we know a problem like this or similar problems like this that you'll see in the future will be a binary search, and how to identify that? So the first thing you want to actually understand by reading the problem is there a bound, or is there a range of numbers that we have defined to us that are going to be basically a possible solution? And so in this case, a range of possible solutions is going to be the max k that you can have and the minimum k you can have possibly. And so our minimum k, as we mentioned in this example, is going to be equal to 1, and our max k is going to be equal to 11. And these are all the possible values, because going over 11 is redundant, and and you need to at least eat 1 banana an hour to actually progress in this problem. So we know that these are our bounds. And so since we know that 1 to 11 are our bounds here, we can actually start calculating this in a way to get as close as possible to our targeted value, which is going to be, in this situation, h, or how long the guards are gone for. So we need to get to eat within h hours or less than h hours, because if we take longer than h, then we've basically not been able to solve the problem. And so as we're trying to approach this h value, or get as close as possible to this h value, or satisfy this constraint, we can basically use binary search by seeing that if the eating speed is actually not satisfying this h value, then we can move the left pointer up, so then we can actually start eating or calculating eating speeds in a range that are possible. And then if it's actually completing or successfully eating, then we can actually lower the eating speeds to see if there's a possible lower value that we can eat at. So knowing this trick will actually help you in the future to identify this binary search problem, and I hope that makes sense. So let's actually go to coding this and see how binary searches can be applied in code, and how we can figure the solution out here. So let's code the solution here. I'm going to be using Java. So we can start off by actually just initializing our k value, which we know we're going to have to return, and then return that value here. And so now let's start with that binary search approach that we kind of went through. And so we need to define our left and right pointer, which is going to be, for our left pointer, min k, which is equal to 1, and then our right pointer, which is going to be max k, is going to be equal to the maximum bananas in a single pile. And so we need to actually figure that out here. So we can write a simple enhanced for loop in Java, and then go ahead and make max k equal to the maximum value that we see in this array. And so we do max k comma p, and so that will give us the maximum value in the array. So now we can actually start the binary search aspect here, and in order to do that, we'll need to make a while loop where we define our left pointer to be less than or equal to our right pointer, and then first thing we need to figure out is our middle pointer, which is going to be mid, and the way to do that is basically add the left pointer plus the right pointer, and then divide that by 2. That will give us the middle. So now what we need to do is actually calculate how long it's going to take us to eat this. So we can figure out the current hours, so current h, which is what I'm going to define it as, how long it's going to take us with using this speed. So mid is going to actually be our k here, our placeholder k value here, and so let's go ahead and calculate this. And so as you know, the time complexity of this will be log kn, and the n aspect of it comes over here. So let's go ahead and make an enhanced for loop here, and then go ahead and calculate the current h to add the amount of time it takes us to eat this pile. And you remember the formula that we wrote, which is going to be math seal, which is going to just round up this this value. So it's going to be p divided by mid, and so that's going to show it, basically tell us how long it will take us to eat this pile, and we'll add all of that together. We actually need to cast this to a double, so we can actually get the decimal value and round that up. And so that will show us how long it will take us to eat this with the current speed. And so from there we can actually define if our current h is less than or equal to the h, which means that this actually is a valid valid value. So we're actually going to eat all these bananas before the guards come back. We know that, so we can go ahead and make k equal to this value, which is going to be k is equal to mid, and then we can move the right pointer to be less than the mid value here, so then we can actually see if we can eat this faster, and if it's not possible, then we'll return that k is equal to mid here below. And so if this is not possible, which means else, so this is actually not a valid value, so we need to actually pick up the speed here, and so eat faster. So we can redefine min k is equal to mid plus 1, and so this will increase the speed, and this should be right. And so let's just verify all the syntax is correct, run this here. And so you can see that when we submit it, our solution is accepted, and our runtime is pretty good here. So yeah, that's how you solve this problem in using binary search. I hope you enjoyed. Please leave a like and subscribe if this was helpful. Thank you.